Okay. Talk about these different theorems. Voice off, guys. As the BBA, students will be able to use properties of tangent, secant, and chord. We talked about what those were in the first place in section 9.1 about a week ago, and we're finishing up this section today. We talked about the idea of if a line is tangent to a circle, and it's perpendicular to it. It's perpendicular to a radius. I know we talked about this again. I said that. Okay, then we went through these problems and we figured whether or not to determine how we could determine if they were tangent to it. Yes. And we went through the first four, correct?
We did two sections of notes and after.
We did the first four, correct?
Yes. On the next page.
Okay, right here.
Eternal tangent theorem.
Eternally going forever.
Well, I can't see what it says.
It says external tangent theorem.
See, I said internal.
External means what?
Outside.
Outside, right? You're like outernal. Tangent segments from a common shared external point are congruent. So here, what would be congruent to what?
J would be congruent to
JK and IK.
Segment JK would be congruent to segment IK.
Hey, that's my whole initials.
What's your name?
Irene. I have
My
all
great
the-
grandma's name.
Grandpa.
If an Asian was singing Irene, that's how it would sound like.
Okay, my favorite
Well, I
part
have
about
grandma
this whole
Vera.
family
I have
tree
grandma
is that there's
Christine, I have grandma
she's
Paula, grandma
grown
Charles,
and
I have grandma
Felix and like
Howard.
like
Oh,
Hispanic
man.
names. And then
Oh, I
there's
cracked myself. I can't repeat it.
yeah.
Hey.
Say it, please.
No, so segment JK.
Aubrey, the way she said
Voice stop, guys. Segment JK is tangent to circle L at point K. Segment JM is tangent to circle L at point M. Find the value of x. What do we know about these two tangent segments? They're congruent because they're both tangent to the same circle and they both come from the same external point, J. If they came from different points, like if this one came over here from this point, like I don't know, L. No, I'm gonna use L. What can I make the shape into? R. Okay. Then they wouldn't be congruent. But because they go to the same point, they are congruent. So we set them congruent and then set them equal and solve.
You said that really hard. Why? Are you Wreck-It Ralph?
Maybe. Right. Same days.
What are you doing, you
I've never heard of that.
Okay. So how would we?
Five.
Okay. Solve this. Do some math.
I don't yeah. When your brain moves faster than
Right.
I actually have that problem a lot.
Yeah, I do too.
Yeah, but that's not what I'm trying to find. You have to figure out the line.
Is it though?
It says find the value
Just
of
find
x.
X.
Oh, let's go!
Can we just do this the whole time then?
Take this one problem so over and over again.
Oh,
Okay, so everyone do number 5 again.
I'm
No.
good.
I'm good.
Yeah.
Where are we going?
You
Where's
don't
the valley and then
We're going to number 6.
Here's the room.
Let's go together.
Evan.
Yeah.
Evan's gone.
Number 6. Find the value of x. X is like right here. And find the perimeter of this quadrilateral four-sided polygon.
You just add them all together?
Yeah, but you still got to find the value of x.
Or we can probably divide
Wait.
them, I don't know.
Or like
Divide x5.
Hard knock life.
So I have x5.
No.
Okay.
Okay.
Oh, I figured it out. Let's do that.
Okay.
I can't. You're supposed to
All that
add
from
those all
that.
together and then you have to like subtract or divide it by 360 or something like that, or like subtract it.
Oh, wait, just kidding, I did figure it out.
Hold on.
So, x will equal 6, right? Yes.
12 minus
Yeah.
20.
No, 8. Yes. Can you just tell us how to
Wait.
really should.
Cause he's a horrible dictator.
No, wait,
Awesome.
nine.
He's
This
not.
is
It's
Yeah,
missing
well,
one.
yeah,
five. It's five, just that little section,
5 is just this little section,
and 13 is the other little section.
and 13 is just this little section.
Oh.
What would this part be? So if this is 13, what would this part be? Just from here to here.
Oh, so it's 7.
So would it be 12?
So this
Seven.
part, first of all, let's make sure we're on the same page, guys. Before we go any further, catch up. Okay. So if this is 13, this point of tangency, this external point is 13 on this tangent. Then this same external point to a point that's on point of tangency would be 13 as well. There's two tangents coming from the same common external point, common external point. They'll both be the same length. So that means the whole thing's 20, this part's 13. What would here to here be? 7, right? Okay, would this be the same as something that we might need to know? Which is x is 7. Okay, are we done once we found x?
No.
No, that's half the problem. We still need to find the other half. We need to
Oh,
figure out what the perimeter is. Okay,
18.
so if this part here is 12, can we figure out what this is? It's 12, right? Because 12 is this external point to this tangent, external point to another tangent, point of tangency, would be 12 as well. So, could we figure out what this little part sliver is? Because that's the only sliver we don't know yet.
It's 5.
It's 5. Same as this little sliver. Common external points to tangents. So we use this theorem really 4 different times here to get this. And now, how would we find the perimeter? Add them all together, right? Out of all the total side lengths, 374. I agree. Add them up, we should get 74. I think it sounds like a professional problem, but it's probably just because she's misspelled person.
That would really be a problem.
Give me the death
It's a joke. If she has a spelling problem, it's personal, because she probably misspelled personal.
Oh.
Professional.
Okay.
That's not that big.
No, I never said that.
She capitalized.
You said that.
No, I did not.
No, that was me being you. That was me being you.
Like you can write that.
That's
right. But that's not true. Lies. Lies.
Aiden?
That was fun.
No.
Question on this one, guys.
Mr. Hassel, have you ever seen my Jacob impression?
You know that it was a six.
He's an Iowa.
Oh, guys, I need to get this full experience of this.
No.
Oh no.
No.
How did I start?
Oh boy.
Oh no, what did you do?
Hi, I'm Jacob, and I am perfect at everything, and I get everything right, and I'm always right. I get 100% on everything, and I got second place. I got second place in a national art competition when I was in 5th grade. But it doesn't matter. I'm better than you, Aubrey. I'm better than you at everything. That's why I got vice president of ACL, and you did it.
I never said the ACL part.
I don't think he ever does
We don't even have that big of hands.
Or
I don't think he ever does the hair.
No, that was the end of it.
Yeah,
That was
his-
my
his
instinct.
hands
That was
are
And
Aubrey's interpretation.
His hands are a lot bigger
But you
than
did it like during, like.
Oh yeah, like with my hair got in my face. If he had longer hair, he would definitely do it.
Oh yeah.
No, I wouldn't.
Oh
No,
yeah.
you would, trust
Oh
me.
yeah, you would.
You
Man, I
totally
ran long hair.
That's what they'll say.
Ponytail.
When I
I
tried-
Yeah.
Yeah.
Did you guys like my Jacob impression?
I love it.
It was
I know.
really nice.
2 chords on the inside. What are we talking about? Okay, so we talked about some different intersecting things, okay? We talked about what happens when we have 2 tangents coming from the same external point. Now we're going to talk about what happens when we have 3 different types of intersections in a circle, or outside of a circle even. Fun, right? Okay. So our first scenario is if we have 2 chords, intersect inside the circle to figure out our lengths. 2 chords intersect inside the circle, we would take EA, part of this chord, times EB, the other part of the chord. So part of the chord times the other part of the chord, separated by where they intersect.
What is it? Yeah, that's what I got.
Segment DE would be times EC, CE, whatever you want to word that. So you do
Common error.
both parts of one chord multiply together equals both parts of the other chord multiply together. Okay. For a secant or two secants, and like the chord but got extended, they intersect outside the circle.
Yeah.
We'll do EA, the external part. EA is the external part
Times
times
EC.
EB, the whole thing. We'll do the external times the whole thing. The external part times the whole thing.
So then it would be EB.
And so EC is the external as well, correct? And then Ian, what would be the whole thing here? ED would be the whole thing. So we have two secants. We'll do the external segment times the whole segment, or times the whole length, is equal to the other external segment times its own whole length. Now keep in mind, we're not doing like this external times this internal or something like that, or this external times this whole thing. We're keeping it in the same secant. So we're not mixing up secants. And just like in chords, we're doing like part of one times part of the other. We're keeping them together. So on one side of the equal sign, you really have one chord to split, and the other chord. Here you have one secant to split, and one secant to split. When we have a tangent and a secant, we will square the one that's the tangent, because it's only the external part. So it's really just like the external times external.
So EA.
Because it really is the same thing. If we think of this, the external, okay, we can think of this as EA times EA. You don't have to write this part down. I just want to show you this. We can think of this as EA times EA, which would be like EA could be the external, while EA is also the whole thing for the tangent. Does that make sense? How EA is the external part, but it's also the whole thing because that's all there is. So it's very similar to secant. And for the secant part, what would we do?
EC. Times EB.
Yep, very good. The same thing you did before. The external times the whole thing. Okay. I mean, that sounds like a professional problem.
What was that? What's the problem?
Are we really starting another
You're good.
lesson after this today? Because I can't.
Questions
No,
on
we're
these
not.
before we start using them?
Yeah, it's not on this what.
I can write it.
Sweet eye.
Aubrey, what are you talking about?
Another
getting all
lesson
sorts of
is
dogs.
Students will bet against.
But why are you doing
Sweaty
all that?
boys,
No, we're not
sweaty,
doing another
wet
lesson today.
boys, always.
We're not doing another lesson.
Sweaty
Use-
wet boys always.
Alright, we're gonna start using this, guys. So hopefully you wrote a good notes up here so we can use it right below this. Okay? So on one, what kind of segments do we have? Are these chords, secants, or tangents? Chords. Two chords intersecting. So can somebody tell me what we would set up when we have two chords intersecting? Ian, thank you.
You do 9 times 5
Okay?
equals 3 times x.
Very good. Before we continue on, we do part of one chord 9 times part of the same chord 5. Then you do part of is equal to part of one chord 3 times part of the same chord x. Same chord. Same. Okay? Yeah, make sense?
Change.
Okay.
Why don't
9
we
times
do
5 is
45.
3 times x is
3x. You
45
divide it.
divided by 3
X
is
equals
15.
15.
You got a box?
Now, are these chords the same length? No, that's okay. They don't look like they should be either.
I like
This
this
isn't
stuff.
Mr. Casa drawing, so I don't know.
Wait,
It kind of looks like something that's flying.
why would they be equal to each other? if
They're not. They're super not equal.
Then I'm confused.
This multiplication thing is
I'm
equal.
confused.
They're not equal.
Only this multiplication ratio
I
is
just
equal.
don't want to.
How do you know they're not equal?
The only time they, the only time
On Thursday.
It's tomorrow, hack day.
Yes, if you bring $1 or $20.
Okay, well, okay,
Or if you
what's the
steal
thing
it
here
all.
that's on the door? You look at the sign walking out of the school on the by the student parking lot. It says Hat Day, Thursday, April 16th.
Whoa.
I looked at it yesterday and I went, wait, is it on Thursday
No.
or was it today?
Katie, what was your question?
Why are they equal?
They're not.
I mean, why aren't they equal? How do you know?
Well, okay,
Besides
so like,
just like looking at it.
well, if we plug it back in, they wouldn't be.
It'd be
Yeah, like
8,
So like this whole thing would be
18.
18. This whole thing would be 14.
Oh.
So they're not equal. That's why.
How? Because
That
three
whole
times
thing is
15
not.
is.
Oh my god.
Three. So okay.
We had an entire class explaining
So-
how this works.
The length of this whole chord is 18. The length of this is 14. Because to find the actual length, you add. Think of an addition postulate because this helps us figure out what x is. Because this
Yes.
multiplication works,
No.
even though they aren't congruent. This multiplication will work no matter what.
Oh, so it's like a
How did you get 32
factor or
times
whatever.
4?
No, wait. Words in the brain.
It's a theorem that helps us find it.
Therems
Did you 32? Oh, okay.
I mean, no.
12.
No, it's not.
Let's look at number.
No, that's the whole. The whole is 12.
Guys,
but you
guys,
have to do that times 50.
Guys,
Yeah.
let's look at number 12.
Has it up for you?
Okay. First of all, what do we have intersecting here? Do we have two chords anymore? No. We have two secants. Okay. Josie, you want to help us like try this one up? Okay.
Okay, hold on. So, you take 3 times x, right? And you take 4 times 8.
Not quite. So 3 is the external times the whole thing x. Right?
Yeah.
4 is the external. What's the whole thing? 12.
12.
It'll be 4 times 12.
That makes more sense. Thank you.
I think so. Okay, so this, real quick, guys, we're not saying these two secants are the same length. That's not what we're saying when we set this equal. We're just saying this multiplication of these two, of the external times the whole, is equal to the external times the whole.
That makes sense because if you
Okay. So 3 times x is,
3x,
4 times 12 is,
48.
then divided by 3, x is equal to 6.
Ow. Oh my god, that hurt really bad.
Questions on that one?
Oh, there's more?
I
Mr.
would like
Gossel, I think
this.
something's wrong with the design of this water bottle. Can you put the lid back on? Is it designed with water bottle?
It might be a
Yeah.
90-10T error. It might be an ID10T error. You ever heard of those?
Idiot.
Is it Dasani? You can taste the dryness of 1,000 suns.
The ID10T error. It's the most common one I see as a teacher.
I think it was like ID 10T error.
Oh, I did.
Are you actually like, genuinely?
Yeah.
I'm
I'm
confused.
confused.
I'm right.
I'm
I'm confused. I'm
You started to erase, you didn't erase, you had.
And where's
Oh.
I said I was an ID 10T error.
Oh.
Right, each one.
Okay.
Okay, see, we're done.
Yeah. Alright. So here on 3, what do we have?
No.
2 secants, okay? Somebody help me set this one up. Owen Van Polo, thank you for volunteering.
setting it up?
I'm setting it up? I'm Mr. Collins, nice to meet you. Oh, speaking of setting things up.
bad enough, Grunt. Okay, so you take 4 times 11 times 8 equals 3 times 3x, 3 plus x.
Very good. So Owen said 4 times 11 because this whole thing would be 11.
Yeah.
And then plus 5 gets you home by 7. Okay. And 3 times 3 plus x. Because this whole thing is 3 plus x, even though the external is 3.
Why wasn't the last? I was like
Yeah, what?
Okay, well look at how the last one was set up.
It was the whole thing was x.
So look, if you look at this last one, the bracket specifically said the whole thing was x. Whereas on this one, it does not. So that's why. Okay. Questions on the setup? Haley.
Why is it 3 times 2?
Okay, so on On number 2,
No, not that. I mean, like, why is it 3 times though?
I
Yeah.
disagree.
Because you always do
That's
the, you,
how it always is. Oh,
you do the
okay.
external times the whole thing.
Oh, okay.
So we did the external times the whole thing.
4 plus 7 is 11.
Okay,
Yeah.
so 4 times 11 is 44. How are we going to do this multiplication here?
You distribute.
So we get 9 plus 3x. Now what?
Subtract 9 from 44, and you divide by 3 from 5.
You get like 11.666666.
Take that.
Close.
Let me pass it.
Kind of scrub.
11.
That's like a broken record.
So it's approximately 11.7.
That's a weird tip.
Yeah,
All of them get divided by 3.
What?
All of them get divided by 3.
just been how it's been working so far. Thought I had to use
Alright, what's my shirt?
Sure. Your question, okay.
I love pictures.
Oi, I guess so. Somebody help me. I want you guys to do number 4 on your own.
My mom always finds like good socks when I'm not with her. It's weird. I wish I was with her when she finds them. What's so funny?
Or you're not.
Sorry, no.
Oh, we'll just discuss them up here.
Huh?
Discuss them up here.
Daddy showed me. Maybe sent me a picture.
I did send a picture.
Here's what mom says up.
Oh, wait, I did it wrong.
Yes, it is.
Here's what mom set it up. Bryce, how do we set this one up?
You would do 6 times x plus 4
Yep,
is equal to x plus 4.
very good.
That's what I did.
Okay, now we distribute the 6. 6 times x is 6x plus 24. What's funnier than 24? 25. That's equal to 12x. How would we solve from here?
Minus x.
My 6x.
Minus 6x.
24, which is not as funny as 25, will equal 6x. 12 times x.
Why can't you, like, add x to 12, but you can, like, multiply it?
Because this is 2 chords intersecting.
No, but I mean, like, in that one, you didn't add 3 to x.
In this one,
Yeah. And
this is a 2 sequence. 2 chords is very different than 2 sequence. For
No, I mean, like, in just any general algebra equation, why can you add, like, you cannot add x to, like, a certain number?
Because they're not like terms. Because we don't know what x is. So we aren't able to combine like terms.
But if you multiply it.
Yep.
Why?
I can explain the math behind that later.
Okay.
Well, technically,
It doesn't.
So 24 divided by 6x is 24 divided by 6 on each side. X would equal
6 and 4.
4. Questions? Okay, on 5, we haven't had this one yet. What is it?
It is the last one.
A tangent and a secant. Somebody want to help me set this one up? Ian.
So it would be x squared
Yep.
equals to 3 times 27.
Very good. Okay. So x squared, when you have a tangent, you just take this, square it. This times itself. Whatever is there times itself. And the secant, you do the same thing we've been doing for the secant the whole time. The external times the whole. 3 times 27. So x squared will equal what?
X squared would equal to 81.
How do we solve?
And then it would just be the square root, and that would be 9.
X will equal 9. Question.
Oh, gosh. Ow.
Okay. you guys do number 6 on your own.
Okay.
I'm going next to it.
Why?
Have like a problem.
Kill the pancreas.
So all the things that
Die to the pancreas.
That's what I was worried about, actually.
That was
Bend
Or
the
binds
knee,
the pancreas.
bend the knee to my pancreas. Get hit by a
pancreas.
car.
Oh my goodness.
It's a sin if you trespass on this land.
Move. Your reflex, but okay.
I was just curious.
Do I have to say that one? I love that one.
Overdose, you just
Wait,
swallow.
I like saying that's what she said.
Put 60 of them.
And boom roasted.
Haley, it doesn't affect you if it doesn't until it gets into your blood.
Didn't get it.
No, she's swallowed that.
What?
His dog.
The old one is
Yeah,
better.
yeah,
She
Harley
has
ate a
one.
syringe.
She has the old one.
That
She
doesn't
goes,
surprise me.
that's
That
hot.
That kid, that
No,
dog
she
needs
used
some
to.
underwear.
Okay, somebody help me set this one up.
Lol.
Haley.
So, you have to do 16.
No
Not-
phone.
oh, not 16.
She did.
I did the wrong one.
I know.
Hey, Josie.
Okay, I'll tell you the
X
next one.
times 5 equals 6 times 10.
Very good. External 5 times the whole thing x is equal to external 6 times the whole thing 10. Here, 5x is equal to 60. Divide by 5, x is 12. Questions on that one?
This is easy.
Right?
It's all about interpreting what you have and how we go from there. Okay. Oh, you guys do number 7 on your own? You guys do number 7 on your own?
Who measures their plate?
We aren't going to do that one.
Yeah, I
We're-
can't
we're gonna
even
say
see it.
9
And like
tonight.
half of the words,
Like half of
the words are cut off.
That Divya went to eat sushi and placed her chopsticks on her plate below. What is the length of one of the chopsticks? Honestly, I thought that was standard.
Why is this?
Me too. I thought it was.
I thought it was Saturday.
Wait, that's not.
Wait, why can't we do that?
No. Oh.
It actually doesn't work
She
out well.
can't do it. She's like me.
No.
I
That's
always
right.
do that.
If you want, you'll just figure it out.
Five.
Which one?
Relatable.
Number 7.
Emails.
So what do we have? What do you
We
have?
have the fancy one. We have the fancy one. Take it one. Take it.
What do you do with the tangent?
You,
No,
I think
wanna
we
do
do it
the-
one,
Yeah.
that one's the
Guys.
like, there's nothing on the
Double check.
Well, what is the tangent?
Oh, I'm a dummy dumb.
Oh.
What's that?
So 12 is. Gage, you wanna help us set this one up, buddy?
Uncle, let's know.
Okay, go ahead, Gage.
So you have to do both squares
Yeah,
equal to x times 10.
very good. So we take for a tangent and a secant, the tangent segment 12. Stop holding hands, boys. Stop holding hands. 12 squared, the extra 1 squared. Exactly, thank you.
We didn't even say no homo.
And the external times the whole
I
thing.
have socks on.
That
makes me not gay.
Wait, you need gloves. 12 squared is 12 squared is 16 times x is 16x divided by 16. Questions on that one at all?
No.
Okay. On number 8. Says review because it is. What? No way, okay. Let's look at number 8 here. If this is 21 degrees, how could we figure out what x is, this measure? Ian.
1 21 is opposite to at the other angle. So
How do you know this angle's 21?
because they're congruent, because it's a what is congruent.
Isosceles triangle. How do we know it's an isosceles triangle?
Because that's a tangent right there.
The rhombi are equal.
The radii. The radii
I was the same.
centered to the extra to a point on the circle. They're both radii, so they're congruent. Isosceles triangle. This is 21. This is 91.
Whoa.
How could we figure out what x is?
42.
138.
180 would be 138.
Questions on that one?
I got 13 in the middle. Wait.
Is that it? Are we getting our homework down?
Mhm.
Yes! I like this stuff.
Do we have to have all in this class to make sure the script?
It's like it's exactly
Whoa.
equations.
Evan,
It's
not
it's
all.
an inside joke. My
Me too.
So now every time
So they're gonna pass it down.
and then
My mom when you're born.
We got color.
Do you guys want to don't do?
Yes.
Alright.
Maybe number 6.
So,
Maybe the last one.
Love don't do.
The last two.
Did you get 9?
How about number 14 and number 15?
here, I got it. Don't do number 13.
Yay.
Alright.
Well, it's unlucky.
Thanks, Dad.
That's my favorite number.
You know,
Are they in color? You actually printed them in
Yeah,
color?
I didn't get one.
I passed it.
Yeah.
So, hold on a minute.
I know, right, Gage?
Yep.
Or
No,
Brian,
that's my
or
favorite.
Henry?
Don't do drugs.
You right, because I do do
Mmm.
He does insulin.
drugs.
So I was kind of like.